Okay, today we're going to learn how to add and subtract polynomials. Now let's keep in mind that they have to be like terms in order to add or subtract them. So you can only add or subtract, x squareds with other x squareds, an x with another x, like we've talked about before. You can't do the apples and oranges thing. It's got to be apples and apples and oranges if you're going to add. Let's just go over like what is a monomial term, a one term. Well, think of each one of these is going to be a term that I'm going to write down. I can write down just an 8. That is a term. A 3x is a term. As long as there's no mathematical term in or function in the middle of the two, then that makes it a term. So it's not like 3 plus x, that means 3x, and that's just one term. You can have 7x squared. You could have 9x squared y squared. You could have, 7ab squared y cubed. I mean, there's no plus or minus or anything in between here. So this whole thing, this is one term. This is one term. This is one term. So these are considered monomials when they are just one term like that. So binomials are going to have two terms in them. So it's a two-term polynomial. And then polynomial is the term that we use to describe all of these, anything with some of these variables in them. So if you have something like x plus y or x plus 3, that is a two-term polynomial, or what we call a binomial. So you could have 3x plus 7y. That is a binomial. There's two terms in it. Here's one term and here's a second term. Those are some good examples. If we have a trinomial, then it's going to have 3 terms in it. So it's a 3-term polynomial. And just notice it's going to have like that plus or minus in there in order for, each term. So you could have something like 3x plus 5y minus 8z. Well, that's a 3-term polynomial because you've got 3 terms in it. 3x is a term, 5y is a term, 8z is a term. Some of our most common trinomials that we see are something like x squared plus 2x plus 10. So that's a 3-term polynomial. X squared is a term, 2x is a term, and 10 is a term. All right, so what are we going to do with these? We're going to start adding and subtracting them, and you're going to have to pay close attention to what you're doing with each of these polynomials. So this is a 3-term polynomial, and I'm adding it to another 3-term polynomial. Well, we're going to combine those like terms, and there's several different ways that you can do this. A lot of people like to use different symbols. So if I'm going to say, okay, here's a 2x squared, here's another x squared. So that makes 3x squareds. Then, so you might put a circle around the first one. You might put a box around the other terms, a positive 3x and a negative 5x. And always think that sign is always going to go with it. So that makes minus 2x. I can join those two terms together because they're both just an x. Then our last term is we've got a positive 2 and a negative 5. So you notice how you can just do different symbols to make sure you're getting them all. That's going to make minus 3. So you've combined those like terms and you've written that as a resulting polynomial, which is a trinomial because you've got 3 different kinds of terms in there. All right, so we're going to do it again. This one's going to be subtraction. So just notice I'm subtracting these two polynomials, which means, remember, if you ever have that minus sign on the outside of something, that means you have to distribute that minus sign to both of those and change those signs inside that polynomial. So we've got to do the same thing here. So I'm going to rewrite this without the parentheses, distributing that negative sign, or that minus, since those are all being subtracted. That means each term is being subtracted, so we're going to have to change the signs on all those terms in that polynomial that is being subtracted. Not the first one, just the second one, the one that's being subtracted. So 2x squared plus x minus 4 minus that x squared, that makes that a positive 4x, and then minus 1. Now we're ready to go combine those like terms. So we've got 2x squared and a negative x squared, so that makes 1x squared. Then we have a positive x and a positive 4x, so that makes 5x. Then we have negative 4, negative 4, and a negative 1, and that makes negative 5. And that is your final answer. All right, another way to do it is just to make sure that you stack those like terms together. And sometimes this is easier if they get a little bit longer. So just be very careful. Like, look at the terms in number 3. We've got x squared, y squared. Well, that's not the same kind of term as just an xy. The variable and the exponents have to be the exact same. So I can only add it with another term that has those variables and those exponents the same. So we've got the xy's, that's considered a like term, and then the xy squareds, those are like terms. So when they're stacked, it makes it just a little bit easier, because then this is an add. Make sure you note that. So that is 10 x squareds, y squareds. Then we've got 5xy and an 8xy. That makes 13 xy's. And then we've got this negative 3xy squared and a positive 3xy squared. So those sort of cancel out. That makes just 0, and we don't have to write that plus 0 out there. So when they're stacked, if you stack those like terms, it does make it a little bit easier. Now notice in number 4, this is a subtraction problem. So again, on that subtraction, you've got to go change all the signs. We're going to change all the signs, and then that means this is just now adding those like terms. Okay, so we've got 11m squareds plus negative 5m squareds, so that leaves us with 6m squareds. 2m squared plus a 6m squared is 8m. Oh, did I say squared? Sorry, that's just m. And then negative 11 and a negative 17 make negative 28. Okay, so here the key is to make sure you know what you're doing. Am I adding? Then that's easy. I just add those terms together. If I'm subtracting, remember you've got to subtract each one of those terms, so you've got to change the sign in those. Okay, so this is a way to do this also. So we've got 3a squared plus 3ab minus b squared. And we're going to add this 4ab plus 6b squared. Well, sometimes you can just come over here and say, well, I'm going to add this 4ab together. And then I've got a b squared term. So I'm going to add that 6b squared to this b squared. And then you just sort of stack them. And then you can come up with your final answer. So we've got 3a squareds, adding these together. And then 3ab's plus 4ab makes 7ab. And then a negative b squared plus 6b squared leaves us with 5b squareds. Now you could still do the little symbols if you wanted to, and just add them straight across. That's fine. But like I said, it is sometimes easier to stack, especially on these subtraction ones, because then I can go change these signs as I am stacking them. So that makes that a negative 2y squared. When I distribute that, that makes that a positive 4y, so I'm going to stack it underneath the other term that has a y, and then a negative 3. And then I can just add those together. So 5y squared minus 2y squared leaves us with 3y squared. 7y plus 4y, that leaves us with 11y. And positive 8 plus a negative 3 leaves us with positive 5. And so that's our final answer. Just notice those terms cannot be added together because they are not like terms, the y squared, the y, and the 5. So your final answer is just like that. Okay, so now we're going to use it in some word problems. It says the measure of two sides of the triangle are given. So this triangle's side is x squared plus 3x minus 5. This side of the triangle is 2x squared plus 3x plus 6. And it's telling us the whole perimeter is this. Well, we know perimeter means we're going to add up this side, this plus this side, plus this side. So our question is, what is this side? So if we know the whole total, we're going to have to subtract this polynomial and subtract this polynomial. So remember, we're going to say, we've got this 4x squared plus 5x plus 5. And we're going to subtract the x squared plus 3x minus 5. And we're also going to subtract this 2x squared plus 3x plus 6. Well, you see, this is going to get a little long and tedious. So in this instance, you might decide that, well, it might really be easiest to stack these equations. So let's say we've got this 4x squared plus 5x plus 5. We're going to subtract this, which means we need to distribute that negative sign to all of those, making that a negative x squared, a negative 3x, and a positive 5. And now we're going to subtract this one. That's going to make a negative 2x squared. That's going to make a negative 3x. And that will make that a negative 6. So now we're ready to add all those together. So we've got 4x squared minus 1x. Remember, if there's nothing there, there's an imaginary 1 is in front of it. So that leaves us with 3. And then minus 2x squared leaves us with just 1x squared. Then we've got a 5x plus that negative 3x plus another negative 3x. So 5 minus the 3 leaves us with 2. Minus another 3 leaves us with negative 1x. You don't have to write the 1. And then 5 plus the 5 is 10. Minus 6 leaves us with a positive 4. And there's your final answer on that. Okay, so these are not too hard as long as you pay attention to that plus and minus. If they're subtracted, just make sure that you distribute that. Okay, we're going to find the area of the shaded region if 9x squared minus 6xy plus 3y squared is the area of the total region. So we know the total area of this rectangle, that means the whole thing here, is 9x squared minus 6xy plus 3y squared. And 3x squared y squared is the area of the unshaded region. So this little area right here is 3x squared plus y squared. We want to know what's the area of the shaded part. So we're going to subtract, this is the total, subtract out that little white area down there. So that polynomial is subtracted. Again, now you've got to distribute that negative sign to both of those. So let's stack our like terms again. So it's going to give us a negative 3x squared and a negative y squared. So notice I'm going to stack them underneath. They're like terms. We don't have an xy term, so he's just going to come on down. So 9x squared plus a negative 3x squared leaves us with 6x squared. This has to come down because he's part of the equation. And then 3y squared minus that y squared leaves us with 2y squareds. Okay, and that's all we're going to do on this. I think I marked out the other equations that are the other ones that were a little bit harder. So we're going to do that. Just make sure you watch your signs, whether it's addition or subtraction on those polynomials.